Hello and welcome back. This is your host Harshit Sinha, continuing from my previous presentation on greenhouse gas emission and now describing another related interesting topic on measuring greenhouse gas emission under scope 1. Measuring and managing your organization carbon footprints is an essential step in understanding how to reduce your impact on the environment. It can also deliver significant business benefits, cutting energy and resource costs, enhancing your reputation, and helping you to prepare for future climate change legislation. Scopes defined by the Greenhouse Gas Protocol provide a comprehensive framework for categorizing emissions based on their sources. Accurate measurement of these emissions is essential for organizations to manage their carbon footprint, comply with regulations, and contribute to global climate goals. Now let us explore Scope 1 under greenhouse gas emission that refers to direct greenhouse gas emission from sources that are owned or controlled by the reporting company. These emissions typically arises from the combustion of fossil fuels, chemical reaction, and other processes within the organization's operations. Now we shall discuss about the scope 1 direct emission. These emissions are critical component of an organization carbon footprint and are categorized into four primary types. The first is related to stationary combustion. The stationary combustion refers to emissions produced by the burning fuels in fixed equipment such as boiler, furnaces, and turbines. These emissions are typically associated with the energy generation and industrial process. For example, a manufacturing plant burning natural gas to generate steam would result in scope 1 emission from stationary combustion. The greenhouse gas emission emitted depend upon the type of the fuel used, with the common gas including the carbon dioxide, methane, and nitrous oxide. The Greenhouse Gas Protocol Corporate Standards 2004 states that to calculate greenhouse gas emission, companies should multiply activity data by emission factors, while the US EPA emission factors for greenhouse gas inventories 2022 emphasize the importance of using appropriate emission factors. Emission factors are representative value that attempts to relate the quantity of a pollutant released to the atmosphere with an activity associated with the release of that pollutant. The International Government Panel on Climate Change and IPCC guidelines for natural greenhouse gas inventories 2006 provides guidance on calculating emission. That is, emission can be calculated by multiplying activity data by an appropriate emission factor. The primary greenhouse gas emitted through stationary combustion is carbon dioxide, and potent greenhouse gas that contributes to global warming. Example of these category encompasses the burning of fuels at fixed locations such as power plant and industrial facilities. The power plant are a major contributor to scope 1 emission from stationary combustion. Coal-fired and the natural gas-fired power plant in particular release substantial amount of CO2 into the atmosphere during the combustion process. Efforts to reduce emission from power plant often involve transition to cleaner energy source like renewable energy like solar, wind or hydro, and improving the efficiency of existing power plant. While the industrial facilities also play a crucial role in stationary combustion related emission, processes such as steel making, cement production, and chemical manufacturing often involves the burning of fossil fuels, leading to significant CO2 emission. Industries can mitigate their emission by adopting more energy efficient technology, switching to low carbon fuel, and capturing and storing carbon dioxide. In conclusion, addressing stationary combustion emission is essential for mitigating climate change. Reducing emission from power plant Industrial facilities and commercial building requires a combination of technological advancement, policy change, and investment in renewable energy source. By transitioning to a low carbon economy, we can reduce our reliance on fossil fuels and limit the negative impact of climate change. Now we shall discuss about the mobile combustion as scope 1 direct emission source. The mobile combustion covers emission from combustion of fuels in company owned or controlled vehicles such as car, trucks and aircraft. These emission occurs when an organization uses vehicle for transportation of goods, services or employees. Similarly to stationary combustion, the primary greenhouse gas emission released are CO2, CH4 and N2O, with the amount varying based on the fuel type and vehicle efficiency. Reducing mobile combustion emission can involve transitioning of electric vehicles or improving fuel efficiency. The US EPA notes that mobile source emissions are those that result from the combustion and evaporation of fuels from vehicles and other mobile sources. That is EPA 2022. This category includes emission from vehicles and mobile equipment owned and or controlled by the companies such as cars, trucks, ships and airplanes. The formula for calculation largely rely on three factors such as distance traveled by the fuel efficiency multiplied by emission factor. Alternatively, it can also be calculated taking account of fuel consumption and emission factors. Mobile combustion is a critical component of an organization's carbon footprint, especially for companies with large fleet or significant logistic operation. The emission can vary widely depending on the types of vehicle used, their fuel efficiency, and the distance traveled. Organization can reduce emission from mobile combustion by adopting more fuel efficient vehicle using alternative fuels such as biodiesel or ethanol, electric vehicle, and optimizing route to minimize travel distance. Regular maintenance of vehicle to ensure they operate efficiently can also help low emission. By understanding and managing mobile combustion emission, companies can make informed decisions that contribute to sustainability goals, improve energy efficiency, and reduce overall environment impact. Now we shall discuss about the process emission under scope 1 direct emission sources. The process emission occurs during chemical reaction necessary for industrial production excluding combustion. These are typically found in sectors such as cement manufacturing where CO2 is released during the conversion of limestone to lime. Other example includes emission from steel production and the chemical industry. These emissions are intrinsic to the manufacturing process and can be reduced through technological advancement or process modifications. The greenhouse gas protocol explained that the process emission are emission from physical or chemical process rather than from fuel combustion. These emissions result from the physical or chemical processes other than the combustion, such as cement production, chemical manufacturing, or metal smelting. The general formula for calculating emission from process combustion is emission is explored as a quantity of material process either as input or output with process emission factor. Process combustion refers to greenhouse gas emission resulting from the chemical or physical transformation of material during industrial process. These category falls under scope 1 emission which includes direct emission from source that an organization owns or controls. Unlike stationary or mobile combustion, where the primary purpose of fuel burning is to generate energy, process combustion involves burning fuel as an integral part of a manufacturing or production process. The common industries that generate greenhouse gas emission through process combustion include cement production, steel manufacturing, food processing, paper pulp supply, metal production, and the chemical industries. For example, in cement production, limestone, that is calcium carbonate, is heated to high temperature in a kiln, resulting in the release of carbon dioxide as the limestone decomposes into lime, that is calcium oxide, and carbon dioxide. Similarly, in steel manufacturing, the reduction of iron ore in blast furnaces release significant amount of carbon dioxide. Managing process combustion emission is a challenging because they are intrinsic to the production process. However, organization can reduce these emissions by adopting more efficient technology, improving processes control, using alternative material with lower carbon content, or capturing and utilizing emitted CO2. Understanding and accurately reporting process combustion emission is crucial for companies looking to minimize their environmental impact and meet regulatory or voluntary greenhouse gas reduction targets. Now we shall discuss the most important scope 1 direct emission source is fugitive emission. Fugitive emission refers to unintentional release of greenhouse gas during industrial process, often due to leak of equipment such as valves, pipelines, or storage tank. These emissions are common in industries like oil and gas, where methane leaks from pipeline or during drilling operation can significantly contribute to an organization's scope 1 emission. Proper maintenance and monitoring of equipment are essential to minimize the fugitive emission. The IPCC 2006 defined these as emissions that are not physically controlled but result from the unintentional or intentional release of greenhouse gases. The general calculation of emission is done knowing the amount of gas released with the global warming potential. However, fugitive emission occurs from the unintentional or intentional release of greenhouse gas, including leaks from equipment, refrigeration, or venting and flaring activities, whose calculations are as follows. The refrigeration leak here means emission from refrigeration leaks due to the operation of air conditioning and refrigeration equipments. The next is equipment leaks. Emission from leaks or other gas like methane or sulfur hexafluoride. The other here is main venting and flaring. Emission from release of gas through venting, that is intentionally released, or flaring, that is combustion of gas during operations. The example here shows that unlike emission from combustion, fugitive emission do not result from fuel burning but rather from leak equipment malfunctioning or evaporation during the handling process and storage of gas and liquids. Managing fugitive emission is a challenging due to their often invisible and unpredictable nature. However, organizations can mitigate these emissions by conducting regular maintenance and inspection using advanced detection technology like infrared cameras and implementing better seal and containment methods. Addressing fugitive emission is crucial not only for regulatory compliance but also for reducing an organization's overall carbon footprint and its contribution to the climate change. Owing to my previous slide, we have discussed stationary, mobile, process and fugitive emission largely based on industrial sector. Now we shall see agriculture emission under scope 1 direct emission as a source. Agriculture emissions are significant component of scope 1 greenhouse gas emission as they stem directly from activities on farms and other agriculture operations owned or controlled by an organization. These emissions arise from several key sources including enteric fermentation, manure management, and rice cultivation. Each of these processes contributes to release of potent greenhouse gas emission, primarily methane and nitrous oxide, which have much higher global warming potential than carbon dioxide. The US Environmental Protection Agency inventory of US greenhouse gas emission and sinks contain detailed information on emission factor and calculation method for agriculture activities. Now we shall take the first one is the enteric fermentation. The enteric fermentation is a natural digestive process in ruminant animals such as cattle, sheep, and goats, where microbes in the stomach decompose and ferment food. This process produces methane as a byproduct, which the animal then expel primarily through bleaching. Methane is a potent greenhouse gas emission with a global warming potential approximately 28 to 34 times greater than CO2 over 100-year period. Enteric fermentation is one of the largest source of agriculture greenhouse gas emission. The Food and Agriculture Organization Emissions Database offers data and tools for estimating agriculture emissions, including enteric fermentation and rice cultivation. The formula for calculating emission from enteric fermentation is based on number of livestock multiplied by emission factor per animal. The second is related to manure management. The manure management involves the handling of storage and treatment of animal waste, which can release both methane and nitrous oxide. Methane emission occurs during the anaerobic decomposition of organic matter in manure, particularly when it is stored in lagoons, pits, or under anaerobic conditions. Nitrous oxide is released during the microbial process of nitrifications and denitrifications that occurs when manure is managed or applied as a fertilizer. The Intergovernmental Panel on Climate Change, their guidelines for national greenhouse gas inventories provides a detailed methodology for calculating emission from enteric fermentation, manure management, and rice cultivation. The formula for calculating manure management emission is amount of manure managed multiplied by the emission factor for manure. Next is related to the rice cultivation. The rice cultivation is another significant source of methane emission due to the anaerobic condition in flooded paddy field, which promote the decomposition of organic material. The process releases methane, which escape into atmosphere primarily during the growing season. The level of emission depends on the water management practice, soil type, and organic inputs. The formula for calculating emission from rice cultivation is based on area of cultivated rice field multiplied by emission factor, that is methane emitted per unit area of rice field. Now we shall discuss additional source, that is emission done by the land use changes under scope 1 direct emission sources. The land use activities such as deforestation and peatland drainage are significant source of greenhouse gas emission falling under the scope 1 emission. These emissions are considered direct because they result from activities that are organizations own or controls. Change in land use, particularly deforestation and peatlands drainage, lead to a substantial release of carbon dioxide and other greenhouse gas, contributing significantly to climate change. The Intergovernment Panel on Climate Change has identified land use change as a significant contributor to global greenhouse gas emission in its sixth assessment report. The IPCC estimated the land use change accounted for approximately 23% of the global anthropogenic greenhouse gas emission between 2010 and 2019. The formula for calculating emission due to land use change is based on area of the land converted multiplied by the emission factor for the land use change. The first is now related to deforestation. The deforestation involves the clearing or thinning of forests to make way for the agriculture, infrastructure, or other land use. Trees and forests act as a carbon sink, absorbing CO2 from the atmosphere through photosynthesis. When forests are cleared, the carbon stored in trees, vegetation, and soil is released back into the atmosphere as CO2, a process that can take place over a short period, that is, burning of biomasses or more gradually decomposing of organic matters. The formula used for calculating emission from deforestation is area deforested land multiplied by the carbon stock per unit area multiplied by deforestation. The next is related to peatland drainage. The peatlands are wetlands that store large amount of carbon in their waterlogged soils. When peatlands are drained from agriculture, forestry, or other purposes, the water table is lowered, leading to the oxidation of organic matter stored in the peat. This process releases significant amount of CO2 and some case methane into the atmosphere. The peatland drainage is particularly concerned because the peat soil contains for more carbon per unit area than the most other land type. The formula for calculating emission from peatland drainage is area of drained peatland multiplied by the emission factor of peatland drainage. While talking about the mitigation and management, managing emission from land use change involves avoiding deforestation, promoting reforestation, and restoring degraded peatlands. Companies can also adopt sustainable land management practices that maintain or enhance carbon storage. Understanding and mitigation these emissions is critical for organizations looking to reduce their carbon footprint and contribute to global climate goals. Here we want to point out that in our last 6 slides, the formula represents general approach to calculating scope 1 emission across various categories. Accurate data collection and appropriate emission factors are essential for reliable greenhouse gas accounting. The specific emission factor and data requirements can vary based on the industry, geography, and type of fuel or process involved. Now we shall discuss how Scope 1 emission should be measured. Scope 1 emission, which are direct greenhouse gas emission from source owned or controlled by an organization, can be measured using various approaches. Each offers different level of accuracy and feasibility depending on the specific operational context. There are several approaches to measuring scope 1 emission, each with its own advantage and application. The three primary methods are: first is the direct measurement. Direct measurement involves the use of sensor and monitoring equipment to directly measure the emission from source. This method provides the most accurate data and is commonly used in facilities with a continuous emission monitoring system, especially in industries like power generation or large-scale manufacturing. Direct measurements are crucial for capturing real-time emission data and are often required for regulatory compliance and reporting purpose. The Intergovernmental Panel on Climate Change, that is IPCC, notes direct measurement of emission can provide the most accurate result but is generally more expensive than other approaches. The next is based on the calculation based approach. Calculation based approach estimates emission using activity data such as fuel consumption and emission factor, which represent the average emission per unit activity. This method is widely used due to practicality and lower cost compared to direct measurement. For instance, emission from stationary combustion can be calculated by multiplying the amount of fuel consumed by its corresponding emission factor. While less precise than direct measurement, this approach is effective for routine reporting and can be improved by using more specific emission factors relevant to fuel type and combustion technology used. The Greenhouse Gas Protocol states that most companies will need to use calculation based methodology to quantify their greenhouse gas emission. Further, the US EPA provides emission factor for various activities and that states that EPA has developed emission factors for many industrial process and activity. The next is related to mass balance. The mass balance method calculates emission based on the principle of conservation of mass, where the amount of greenhouse gas entering and leaving a process is measured and the difference is attributed to emission. This approach is particularly useful in processes where greenhouse gas are inputs, outputs, or byproducts such as in chemical manufacturing. It provides a more comprehensive understanding of emission but requires detailed knowledge of the process and its input. The European Commission explained the mass balance approach can be useful when the inputs and outputs of the process are well known but direct emissions are difficult to measure. Each of these methods has its strength and is suited to different situations. In conclusion, we can say that organizations often use a combination of these approaches to comprehensively measure their scope 1 emission depending on the nature of their operation and the specific emission source involved. The choice of method of measuring scope 1 emission depends on balance between the accuracy, cost, and the specific requirement of the industry and regulatory framework. Now let us see an example of a scope 1 emission in manufacturing sector. The slide provides an example of breakdown of scope 1 emission for an emission from source owned or controlled by the company. The table shows three main emission sources. Natural gas boiler. These accounts for the largest portion at 5,000 ton CO2 emitted annually, representing 50% of total scope 1 emission. This likely comes from the stationary combustion used for heating or industrial process. The second is company vehicle. The second largest source is emission from the company owned vehicles, contributing 3,000 tons of CO2 or 30% of the total. This represents mobile combustion source. The third is process emission. These accounts for 2,000 tons CO2 emitted or 20% of the total scope 1 emission. Process emission typically comes from chemical or physical process involved in manufacturing separate from energy use. So the total scope 1 emission for this example company sum up to 10,000 tons CO2 emitted annually. This breakdown helps the company identify where their direct emissions are coming from, with stationary combustion from natural gas boiler being the most significant source of potentially target for reduction efforts. Now at the end, we shall now discuss about the strategies for reducing scope 1 emission. Reducing scope 1 emission, which are direct greenhouse gas emission from source owned or controlled by an organization, is crucial for achieving sustainability goal and mitigating climate change. Strategies for reducing scope 1 emission are crucial for organizations aiming to decrease their direct greenhouse gas emission. Companies can adopt several strategies to reduce these emissions, such as the first one is energy efficiency. Enhancing energy efficiency is one of the most cost-effective methods to reduce scope 1 emission. Energy efficiency improvement can be made across various areas including industrial process, building systems and equipment. For example, upgrading to energy efficient boilers, optimizing heating, ventilation and air conditioning system and utilizing advanced control system can reduce fuel consumption. By consuming less fuel, companies directly lower their greenhouse gas emission from a stationary combustion source. According to the International Energy Agency, that is IEA, improving energy efficiency in industry alone could reduce global CO2 emission by nearly 20% by 2030. Another method is fleet electrification. The fleet electrification involves replacing internal combustion engine vehicle with electric vehicle. This strategy is particularly effective in reducing emission from mobile combustion sources, while which includes company-owned car, trucks and other vehicles. EV produces zero tailpipe emission, directly reducing scope 1 emission. The transportation sector is a significant contributor to greenhouse gas emission and is transitioning to EVs not only reduces the emission but also benefits from lower operating costs over time. A report by International Council of Clean Transportation highlights that electric vehicles have the potential to reduce fleet emission by up to 50% compared to the traditional vehicles. The next is process optimization. The process optimization involves improving industrial process to reduce waste, enhance energy efficiency, and minimizing emission. This can be achieved through various means such as adopting advanced manufacturing technologies, improving heat recovery, and optimizing reaction efficiencies. In industries like chemicals and cement manufacturing, process emissions are significant and optimizing these processes can lead to substantial reduction in scope 1 emission. For instance, using alternative raw material or adjusting chemical processes can reduce the need for high carbon inputs, thereby lowering emission. The World Resource Institute emphasizes the importance of process optimization in reducing industrial greenhouse gas emission, particularly in energy intensive sector. The next is on-site renewables. Installing on-site renewable energy sources such as solar panels, wind turbines, or biomass generation can replace or supplement fossil fuel-based energy. This strategy directly reduces the need for stationary combustion of fossil fuels, thereby cutting scope 1 emission. On-site renewable offers the added benefit of energy independency and can shield companies from energy price volatility. The US Environmental Protection Agency, that is EPA, notes that businesses adopting on-site renewable energy can achieve substantial emission reduction while also realizing long-term cost saving. The next is related to the leak detection and repair, that is LDAR. Fugitive emission, often from equipment leak in industries like oil and gas, can be a significant source of greenhouse gas, particularly methane, which has much higher global warming potential than CO2. Implementing a robust LDAR program helps identify and repair leak quickly, preventing these emissions from escaping into the atmosphere. According to the Environmental Defense Fund, effective LDAR program can reduce methane emission by up to 80%, significantly lowering overall scope 1 emission for companies involved in natural gas production and distribution. The Environmental Protection Agency, that is EPA, notes that LDAR program can result in significant emission reduction and cost saving by minimizing product losses. The next is related to the fuel switching. Fuel switching involves transition from high carbon fuels like coal and oil to lower carbon alternatives such as natural gas, hydrogen, or biofuel or ethanol. This strategy is especially effective in industries with high energy demand such as manufacturing, power generation, and transportation. Natural gas, for example, emits approximately 50% less CO2 than coal when burned. Moreover, the use of biofuel, which are derived from renewable organic material, can further reduce net carbon emission as they are considered carbon neutral over their life cycle. The International Renewable Energy highlights that fuel switching, particularly to renewable and low carbon option, is crucial for achieving decarbonization in energy intensive sectors. Lastly, the World Resource Institute suggests fuel switching, particularly to renewable or low carbon fuel, can be an effective strategy for reducing scope 1 emission. Implementing these strategies requires a comprehensive approach, including conducting a thorough emission audit, setting science-based reduction target, investing in technology and infrastructure, training employee and changing operational practice, and regularly monitoring and reporting progress. By adopting these strategies, the company can make significant progress in reducing their scope 1 emission aligned with the global efforts to mitigate climate change and achieve sustainability targets. So while concluding, I would say in today's presentation, we have seen scope 1 emission from direct source are significant part of an organization overall greenhouse gas emission and requires targeted strategy to mitigate their impact on the environment. Besides, accurate measurement of scope 1 emission is crucial for organizations to understand their direct climate impact and identify opportunities for reduction. Thus, we continue our journey. It is apparent to explore scope 2 next. So, stay tuned for our upcoming discussion on measuring and managing scope 2 of greenhouse gas emission. Until then, bye bye.